The lesson today will be on graphing systems of linear inequalities. By the end of this lesson, you should be able to graph a system of linear inequalities, including graphing the lines as being solid or dashed lines and shading. The method to graphing systems of linear inequalities would be first to graph each individual line, making sure you determine when the line should be solid, when the line should be dashed. Next would be to graph the line according to the shading. So do we shade above or below the line? Don't forget you can test out a point. After then, you're going to see where the two shadings cross and darken in that area. The darken in area that you just did will be the actual solution of the system. So if your two lines look like this, with shading on the bottom, and the other one looks like this, and let's say that shading is on the bottom as well, the place where they're doubly shaded would be in between right here. So we want to darken in that area so that I know and you know that that is the solution to the system of linear inequalities. So let's see how it works. So let's graph this line first. We start at the -5, which is here. The slope is -2, so I go down 2 and to the right 1, or I go up 2 and to the left 1. There is no equal to sign underneath the inequality, so this line will be dashed. And if I go by the greater than or less than sign, it would be shaded above the line. The other way we can test is by testing out the point 0, 0. If I test out the point 0, 0, I get 0 greater than 0 minus 5, so that's 0 greater than -5, which is true, so we shade on that side of the line, above the line. Now we graph the other line. So we start at the +3. The slope is +1, so I go up 1 to the right 1, or down 1 to the left 1. This line is going to be solid because of that equal to sign underneath. And if I test out the point 0, 0 on this one, 0 less than or equal to 0 plus 3, 0 less than or equal to 3, that is definitely true. So we shade where that 0, 0 is, which would be this way. So now we can see where the two shaded areas intersect, and that would be right here, and everything in between. So we doubly darken that area so that we know, and everybody else knows, that that's where the solution would be. On a multiple choice test, what it's going to look like is you'll have the one line, the solid line, the one dashed line, and the only thing they're going to give you on the multiple choice is that one area that should be darkened in. So it's up to you to figure out which area is the correct one. Let's move on to another example. So let's graph the bottom line first. We start at the +4, and because the slope is -2/3, we go down 2 and to the right 3, or we go up 2 and to the left 3, and because it's equal to, that line is solid. If I test the point 0, 0, 0 greater than or equal to 0 plus 4, and is 0 greater than 4? Definitely not. 0, 0 is over here. Because that's not true, we shade on the other side of the line. Now we try the top equation. Most of you like to manipulate the equation, so if we subtract 2x from both sides, then we get 3y less than -2x plus 6, and then divide by 3. So we get y less than -2/3 x plus 2. So our line is going to start at the +2 and go down 2 and to the right 3, or up 2 and to the left 3. This line is going to be dashed because there's no equal to sign underneath. And then we test out a point. If I plug in 0, 0, 0 plus 0 is 0. Is 0 less than 6? Definitely so. So in this case, we shade where the 0, 0 is. So now we look at the system, and because there's no doubly shaded part in this problem, we're going to have no solution. Okay, on to the next example. Okay, now let's graph this one. If we graph the first equation, that's going to start at the positive 3, and less than is underneath. The second equation is absolute value. The vertex is at negative 4, 0, so negative 4, 0 is here. The slope is 1, so we go up 1 to the right 1, and then up 1 to the left 1. That line will be dashed. And because the inequality is greater than, we look above the vertex and shade there. So the doubly shaded part is the triangle in between the two, the line and the absolute value. So when we talk about inequalities with absolute value, greater than is above the vertex. Sorry. And less than is below the vertex. Do not think of it as inside, outside. Think of it as above and below the vertex. Example. So, let's graph the first line first. So down to negative 2. The slope is positive 3, so we go up 3 into the right 1. Up 3 into the right 1. The line is equal to, so it's a solid line. And it's less than, so that's underneath, or you can test the point 0, 0. Then we do the second line, so that's positive 4. You go down 1 to the right 1, or up 1 to the left 1. This line is going to be dashed because there's no equal to sign. And it's greater than, so in that case it's above the line. Or you can test out the point 0, 0. And so you can tell that the doubly shaded part is bounded by these two lines, right, and everything in between. Just like that. Okay, now you pause the screen and try the next one on your own. Okay, now that you've tried it, let's see if you're correct. So for the first equation, we have to subtract x from both sides in order to graph that inequality. So we start at the negative 3, we go down 1 to the right, or up 1 to the left 1. That line is going to be dashed. It's greater than, so the shading is going to be above. On the second one, we're going to add 6x to both sides. So we start at the positive 1, we go up 6 and over 1, or down 6 and to the left 1. That line is going to be dashed. Right, and it's less than, so the shading is going to be below, which is over here. So you can see that the doubly shaded part is right here. Just like that. On to the next one. So the first equation is at negative 2, and it's dashed because it's not equal to. Greater than is above that line, so it's up there. The next one is a absolute value, so that's at negative 2, 0. And then you have to go down 1 and to the right 1, and down 1 to the left 1. That line is going to be solid because it's equal to. And it's less than, so the shading is going to be below. So the doubly shaded part is this tiny triangle right here. Okay, so for this one, we're going to do the absolute value first. So we start at the negative 1 and 0, and we go up 2 and to the right 1, up 2 and to the left 1. That line is going to be dashed. And greater than is above the vertex, so that's up here. The other one is a straight line, so it starts at the positive 1, it goes up 1 and to the right 1, or down 1 and to the left 1. That one is going to be dashed. That shading is going to be below. So because there's no areas that intersect on this problem that has no solution. Okay, your homework for this weekend is to join the discussion titled Chapter 3 in My Big Campus. And answer this question: what is the solution of a system of inequalities?